Friends, a very warm welcome to all of you in today's class. We have started a series on physical geography and we are already done with the first lecture that was concerned about the latitudes and the longitudes. Today we'll be dealing with the second lecture about the interior of the earth. But before we start today's lecture, I will give you a brief outlook of how we will approach physical geography. I have divided the physical geography in the series of physical geography, not the physical geography, in three parts. First one is the geomorphology. Second one will be your climatology. And third one will be your oceanography. Okay? Now, before I explain the things, just give me a thumbs up quickly if I am audible, visible. In the comments, you can say if I am audible, visible. Okay. Okay. So, geomorphology deals with all the features related to lithosphere. It can be mountains, plateaus, interior of the earth, and all the other features. Then the climatology will deal with the climate and the weather, which will include the rain, the snow, the winds, and other physical features. Finally, the oceanography will deal with the oceans, the currents, and the tides, and all the other features. This is how we will deal with the physical geography, primarily dividing into three. And today we're starting with geomorphology, and today's lecture is the interior of the earth. Why interior of the earth? Why do you think we should start with the interior of the earth and not with something on the outside part of the earth? Because if you look at earth, you will have soil. What is soil made up of? How is it made up? By weathering and erosion of rocks and mountains. So soil is made up of weathering of rocks. And then how are the rocks formed? By the help of lava. You know, the igneous rocks are formed with the help of lava. If you carefully observe, the lava comes from within the earth. It comes from the inside of the earth. That is why we are starting from the inside, starting from the very base, from where all the processes start. Is it clear? So how do we study the earth? How do scientists and the researchers approach about the interior of the earth? There are basically two sources, the direct sources and the indirect sources. Okay. The direct sources include the deep sea drill, the volcanoes, and the mining activities, while as the indirect sources will include meteors and the gravitational anomaly and seismic waves as well. Deep sea drill, there has been a 12-kilometer deep sea drill done by Russia in the Arctic region called the Kola. This is very important. Remember the name, the Kola drill is the deepest drilling activity that is taking place on the earth up until now. Volcano, it's the lava coming to the earth. This helps us to understand what is going inside of the earth. When lava comes to earth, you will realize that it is in semi-solid or liquid state. That means there is something within the earth that is not solid, but there are many other physical features present within the earth. And mining activity, with the help of mining activity, you will realize some of the rocks are of different composition. That tells us about the variation in the depths of the earth. If talk of indirect, then there are meteors and the gravitational anomaly. Gravitational anomaly is basically the gravity that we observe at a place when it differs from the predicted value. Why is it differing? Because as we are assuming that Earth is not uniform, that is why there is a difference in the gravitational values at different places on the Earth. It's basically the deviation from the assumed or the predicted value. These are the sources that are used to understand the interior of the earth. There is one more source, that is the earthquake waves or the seismic waves. That are the most important and the most reliable as of now. As of now, seismic waves are very important. Now, all we are doing here, this is very important if you want to learn geography for any exam. It can be UPSC, state PCS, or it can be any other exam, SSC, SSB, all the exams. This is very useful for you because we'll be covering the concepts as well as the facts, like this fact, the Kola, the deepest drill, and so on and so forth. Now, if you have any question up until now, you can ask me. Hello, hello, hello. Hello everybody. Okay, so let's move. to our main topic. The Earth primarily consists of three layers: the crust, the mantle, and the core. If you look at the diagram, first layer is the layer called crust, then followed by mantle, and the innermost layer is core. These are the three important layers of the Earth that you might have heard of. But today we'll dig a bit deeper and learn how these layers vary from each other. What is important in crust and mantle and core. Starting with the first layer, that is the crust. It is the outermost layer of the Earth. Let us assume, don't look at this image right now, I'll explain it later. This is the ground on which we live. Okay, then this is the outermost part of the Earth, that is the crust, the continental crust. Then there will be a part under the water, because Earth has oceans as well as land as well. So this is a part that includes water or the oceans. This is the oceanic part. So that means the crust is not uniform. We will have two types. The first one will be the continental crust, and the second one will be oceanic crust. Is it clear between the continental crust and the oceanic crust? Okay? Okay. See, if you look at this image, you will realize that the continental crust is thicker as compared to oceanic crust. See, the thickness here is more as compared to this. So the first question that you might get is that, is the continental crust thick or the oceanic crust? So the continental crust is thicker than oceanic crust. Remember the words that I'm saying. Thickness, it's about thickness, because after this we'll learn about the density as well. So continental crust is more thick as compared to oceanic crust. Now another question, is the oceanic crust denser or the continental crust? This is about thickness. If you are asked about the density, then the oceanic crust is more denser as compared to continental crust. Is it clear? If you are asked about the thickness, don't confuse between the two, because oceanic crust is more denser as compared to continental crust. Why? Because the oceanic crust is made up of silicon and aluminium. The main constituents of the continental crust are silicon and aluminium, called as Cl, whereas the continental crust is basically made up of silicon and magnesium. So the important points you need to know is that the composition of continental crust is different as compared to oceanic crust, and the oceanic crust is more dense as compared to continental crust, even though the continental crust is thicker as compared to oceanic crust. Are these points clear up until now? If you have any question, you can ask. Okay, I think it's clear. Now, what is the thickness? It is assumed to range from 5 kilometers to 35 kilometers. The thickness is not uniform. It's very important to know that the thickness is not uniform. The variation, it varies greatly from 5 kilometers to 35 kilometers. Clear? It is more at the continental crust as compared to the oceanic crust. Now, look at this diagram. If you look at the diagram, you will see the same thing that I was explaining up until now. This blue color is the ocean and the green color is the continent. The part of the crust under the oceans, this, the line that I'm drawing, don't look at anything else what is under it. Don't go to that level. Right now we're only dealing with this. The part of the crust under this ocean is the oceanic crust. Well, the part of this here, this part is the continental crust, because it lies in the continent. So you understood the difference between the continental crust and the oceanic crust. The minerals, silicon and aluminium, and silicon and magnesium. So this is Sima and this is Seol. You understood the thickness, the density, which is more denser, oceanic crust or the continental crust? Okay, the oceanic crust is more dense as compared to continental crust. These are some of the points that you need to remember for your exam, because this will be asked in some exam, maybe in the state PSCs, if not in the UPSC, that these are some of the pointers that you need to take from the lecture that I've done up until now. Now, if you look at some of the features, then you will realize that the density is also not uniform. It varies from 2.7 to 2.9 grams per centimeter cube. 2.7 to 2.9 grams per centimeter cube. Why is it varying? Because of the differences between the oceanic crust and the continental crust. And this is Sial and Sima that I already explained. Sial is in the continental crust, while its oceanic crust is made up of Sima. The thickness ranges from 5 to 35 kilometers. Now, a very important thing that you need to know here is that, see, this you understood. The red line that I've drawn here has made you understand where the oceanic crust and the continental crust is ending. This is the boundary of the crust. Okay. After that, you will see another layer of mantle. Mantle starts where the crust ends. But what is a lithosphere? What is lithosphere? Anyone knows what's lithosphere? Okay, see, it is a solid part that includes the crust as well as the uppermost part of the mantle. Remember the word uppermost part of the mantle, not the entire upper mantle or the mantle. You might get confused in the exam if the questionnaire asked you, if the question is asked that what is the lithosphere made of, and in the option it's mentioned it's made of the entire upper mantle, then that is not correct. It is made up of crust and the uppermost part of the mantle, not the entire mantle. If you look at this here, this is the end of lithosphere. Clear? So the crust, starting from here, the crust, it can be the continental crust as well as the oceanic crust, and the uppermost part of the mantle. So what you need to remember here is that lithosphere is made up of crust plus uppermost part of the mantle, not the entire upper mantle, but the uppermost part of the mantle. You know why I'm stressing so much on this? Because you will easily get confused. The question comes like that: upper mantle, entire upper mantle, only crust. No, crust as well as the uppermost part of the mantle. And this layer is solid. It is a solid layer. So lithosphere is solid. The crust is solid as well as the lithosphere is solid. It goes up to 150 to 200 kilometers. The depth of the lithosphere is up to 100 and 150. As I told you earlier, what is the thickness of crust? It is 5 to 35 kilometers. Now, lithosphere goes up to 150 to 200 kilometers. So that means it is including all the crust as well as some part of the upper mantle as well. Is it clear? Now, when we move on, we will realize that as we go deep down the earth, there is an increase in temperature and pressure. See, as we go deeper, you will see 1 degree rise in temperature every 32 meters. Every 32 meters you go into the depth, you will see a 1 degree rise in temperature. So as you go deeper and deeper, there will be very high temperature. Is it clear? And the pressure will also increase as well. Pressure will also keep on increasing as well. This is very important that you understand how temperature and pressure are increasing, because that will eventually determine the underlying layers as well, how the underlying layers are there. If you have any question up until now, you can ask anything related to lithosphere, crust, or the upper part of the mantle. Okay. See, all that we have discussed up until now was solid. Now imagine the temperature is increasing at 1 degree per 32 kilometers. What is going to happen? What do you think? When we go deeper, there is radioactive activity going on as well. So the temperature there is very high. So if you look at the image again, the image that we are looking at here is the asthenosphere. because of very high temperature, because of the radioactive activity that is going on inside of the earth, and the increase in the temperature, 1 degree increase every 32 meters, this layer, it's very difficult for the layer to be solid. So that is why the layer will not be solid, it will be semi-solid. Not entirely liquid, but semi-solid. So that brings us to the next layer, that is the asthenosphere. This is the asthenosphere. See, asthenosphere is neither solid nor liquid, but it is semi-solid in shape. Why? Because if you look at the crust, this was our crust. Okay, this is the oceanic crust as well as the continental crust. Then there was mantle. We started with mantle. After this, mantle consisted of 3 parts. First, you have lithosphere, uppermost part of the mantle. After that, you will have the asthenosphere. This is the asthenosphere, but it is semi-solid. I'll tell you why it is semi-solid. Because of the high temperature, it can get converted easily into liquid. But as I told you, not only the temperature is increasing, but the pressure is increasing as well. So when the pressure increases, it will make it into a semi-solid layer. It will not be a solid nor a liquid. Because of the high pressure, it will not get entirely converted into the liquid layer. And because of the high temperature, it will not be a solid, but a liquid layer. So what is this layer? This is the crust, the lithosphere or the mantle, and this is the asthenosphere. This is a very important layer because this is semi-solid due to high pressure and temperature. The question, very simple question if I want to ask you is, why is asthenosphere a semi-solid layer? What are the 2 reasons for that? Answer in the comments. Why is it so? Okay, this is because of the high temperature and high pressure. Both the factors are playing their role. High temperature is causing the rocks to melt in the asthenosphere. However, the high pressure is not letting it melt completely and making it a semi-solid layer. This is a layer, asthenosphere is the layer from where the volcano comes to the earth. This layer contains all the magma, and when there is a volcanic eruption, this is from where the volcanoes will rise and come to earth. So where the volcano come from? Asthenosphere. Is it clear? This layer goes up to 700 kilometers, and this is also included in the upper mantle. Now, one important thing, the crust. After that, you will have lithosphere. You can take down these points. This is a brief summary of whatever I have taught you up until now. The first thing, crust is solid. Okay. Lithosphere. Just keep answering in the comments as I'm writing. Just tell me what I'm writing. Am I correct or not? Lithosphere is solid as well, and it includes what? Crust plus upper mantle, some part of upper mantle, and then asthenosphere. Asthenosphere includes upper mantle, and it is semi-solid in shape. Why is it semi-solid? I hope you have understood, because of high temperature and pressure. So this is a diagram. You can see this is a semi-solid layer. Now we're going deeper and going towards the lower mantle, crossing the 700 kilometer boundary. And when you go to the lower mantle, it's also solid in shape. Very strange that one thing I missed here is that mantle comprises of silicon and magnesium. SiMa. Mantle is made up of SiMa. Okay, when we go deeper to the lower mantle, it's again solid. Very interesting, because up until now we were learning that because of high temperature, the rocks are melting and it is getting converted into semi-solid layer. But now why is the lower mantle then again in the solid state? Why is it not semi-solid? Because the pressure is increasing again. And when you look at this image here, the weight of crust and only the lithosphere was on the asthenosphere, and it got it converted into semi-solid layer only. When you go deeper than this, the weight will again increase. The pressure is going to increase a lot. The temperature will not be that high as compared to pressure. That is why the layer will again be solid. So what is the cause for the layer to be solid? Why is the lower part of the mantle solid again? This is solid again. Why is it solid? because of very high pressure created by the above lying layers. Remember, the words above lying layers are not allowing this layer to get converted into liquid instead of the fact the temperature is increasing at 32 degrees, 1 degree per 32 meters. So this is the layer that goes up to 2900 kilometers. It goes up to 2900 kilometers. Crust thickness that I've told you, 5 to 35. Lithosphere will go up to around 200. The upper part of the mantle ends at 700 kilometers. So the upper mantle will end at 700 kilometers, and then we have lower mantle. This is solid again, and it goes up to 2900 kilometers. Is it clear? We have a solid layer, then we have a semi-solid layer, and then we have a solid layer again. The lithosphere that we discussed here floats on the asthenosphere. Just imagine putting a wooden block in water. You will see the wooden block will move in water. It will not stay at one place. That is exactly what is happening here as well. If you have any question, you can ask me in the comments. Okay, I think everything's good up until now. See, what is happening here is that the lithosphere is floating on. This is the reason for the earthquakes that we will discuss in the next class. Today, we're going to be only with the layers of the earth. These are all the points. Just a second. These are all the points that I've discussed up until now. It goes up to 2900 kilometers. That is the both upper and the lower mantle, mainly composed of SEMA. What is SEMA full form? Just tell me the full form in the comments. I mentioned it 10 times. Density varies. Why does the density vary? You can see the upper mantle is semi-solid and then it goes towards the solid state. That is why the density varies from 3.3 to 5.7 grams per centimeter cube. Then asthenosphere, I already discussed what it is. It's a semi-solid layer. Then finally, 700 kilometers the depth of the asthenosphere, and all these points I already discussed. The portion below the asthenosphere is called a mesosphere. The lower mantle, you can use the term mesosphere as well. Okay, if you want to use a more technical term, it's mesosphere, and it extends up to 2900 kilometers. I hope you have understood these points. I've already discussed each of these points. If there is any confusion up until now about the crust or the mantle or the asthenosphere or where the volcano is, you can ask me in the comments. Okay, looks like good to go. Then we come to our last layer of the earth, that is the core. It is the innermost layer of the earth. It is below the mesosphere. This is the mesosphere, and then we have core. See, here very important thing you need to know is this is again liquid. The outer core, we have divided the core in two parts, the outer core and the inner core. But the question arises, if because of the high pressure the mantle was in solid state in the lower parts, why is the crust again liquid? Why is the outer crust again liquid? Why is the crust in liquid? What do you think? The pressure will work here as well, but why is it liquid? Because it is not composed of silicon and magnesium, but it consists mostly of nickel and iron. The most important component is nickel and iron. N-I-N-F-E. Fe is the symbol for iron. If you know chemistry, it's the symbol of iron. Is it clear? That is why it is in liquid state, because the temperature is increasing and these elements will melt quickly as compared to silicon and aluminium. That is why it consists of a liquid layer. So the outer core will be again liquid. Is it clear? Why is it liquid? This is the first layer actually that is in liquid state. If you was read up till now, we have got with 4 layers. You will see the crust, mantle, they are all either solids or semi-solids. But crust, the core, the outer core precisely is in liquid state. Because of the high temperature, the iron and the nickel in this layer will melt, and this will result in the liquidity of this layer. That is one reason, and it goes up to 5150 kilometers. Starting from 2900 kilometers where the mantle ended, then goes up to 5150 kilometers approximately. This is the depth of the outer core. This is what we are talking about, the outer core. Is it clear? The outer core is in liquid because of iron and nickel. Okay, any questions? We're moving towards the last layer. So if you have any question up until now, you can ask. Okay, I think no questions. Now, The last layer is the inner core, but very interestingly, it is again solid. Very confusing, na? You get a solid layer, then a liquid layer, then again solid. At one place the pressure is working, at the other place it's not working. How can it happen? The reason for the inner core, this layer, to be solid is because the entire weight of the earth is on this. This is the innermost part of the earth. The diagram that we're drawing up until now, if you look, this is the crust. Then we have lithosphere or the mantle, broadly classifying it as upper mantle, lower mantle, or what is the other name of the lower mantle? Tell me quickly. Mesosphere. Finally, you will have outer core. And at last, you will have inner core. Inner core will again be in solid state because of the pressure applied by all the above lying layers. Just imagine every part of the earth, every layer of the earth is exerting pressure on the innermost part of this earth called the inner core. The inner core is in solid state because of that. That is one reason. Is it clear why this is solid and this is liquid? If you have any questions, you can ask me. Okay, now is it clear? Because of the high pressure, it is in liquid state. One more reason for this to be in liquid state is because of the rotation of the earth. So there are primarily two reasons. Because of the rotation of the earth, this is in solid state and the outer core is in liquid state. Just imagine when earth is spinning or the rotating on its axis, the lighter part will be thrown outside and the heavier metals will sink towards the center. So when the outer liquid will go towards outer part, the inner core will again become solid. That is one more reason. Because of the rotation of the earth, one reason. Because of all the pressure being exerted by the above lying layers, another reason it is solid. And because of the convectional currents. You know, when the currents will develop, the lighter parts will go towards the upper area. So this is how the interior of the earth looks like. Starting with the layers, you should know how the layers are there. You will get a solid layer, then a semi-solid layer, then again a solid layer, then a liquid layer, and finally a solid layer. This is all about the interior of the earth. This is the shape of the interior of the earth. So it is the innermost layer of the earth. I already discussed it. Very high density of 9.5 to 14.5 grams per centimeter cube. Because of all the above lying layers, they have caused a lot of pressure there. That is composed mainly of nickel and iron. Nickel and iron, you should know it, NiFe. That is the reason for the outer core that it is in liquid layer and the inner core is in solid layer. This is all we have discussed already. The thickness is up to the depth. It goes up to 6,371 kilometers. Just for the sake of your knowledge, if you want to take it down, these are some of the factual points. If you missed it in case, then the crust is from 8 to 35 kilometers or 5 kilometers to 35 kilometers. Mantle will be up to 2,900 kilometers. And the core will go up to 6,350 kilometers. This is the radius of the earth as well. 6,371 kilometers or 50. It's roughly about this range. This is how there is variation in the different layers of the earth. Now, if you want to look at the chemical composition of the earth, the entire earth, if you're asked about the chemical composition, arrange the minerals in the ascending or descending order, you should know that iron is in the maximum quantity. Iron is 32% iron in the entire earth. Just know we're talking about entire earth. Don't get confused by the question. If we're talking about entire earth, then it's iron. If you're talking about crust only, then it's oxygen. Just make sure that what you're being asked. First, if you talk about the entire earth, then you will have iron. That is the main, followed by oxygen. And at the end, you will have silicon and then other in the minute quantities. This is how you should know, because UPSC won't usually ask you the questions that give me the quantity of these minerals, but it might be asked to arrange these from ascending order, in ascending order, descending order. This is the ascending order: maximum iron, then oxygen, and finally silicon. This is how the entire composition of the entire earth is. Make sure you know what is being asked, entire earth. Now if you're asked about the crust only, then you should know that oxygen followed by silicon and then aluminium. Why aluminium? Because I've already told you it's mostly composed of Cl, silicon and aluminium. This is very important to know how it varies from entire earth to crust. Entire earth, this is your sequence, and for crust only, this is your sequence. So that is the composition of the earth's interior. Now we are left with the discontinuities. What are the discontinuities? These are the discontinuities. There are a few discontinuities that separate different layers of the earth. So we'll start with the first discontinuity that separates the upper crust and the lower crust. What is the upper crust and the lower crust? We won't discuss that right now. That's because we don't have to discuss that. It is only based on the composition of the minerals. We have divided the upper crust and the lower crust, and the discontinuity between the two is called Conrad discontinuity. C-O-N-R-A-D. The Conrad discontinuity here. This is the Conrad discontinuity separating the two crusts. Is it clear how the discontinuities work? No questions up until now? Okay. If we go to next, then there is crust and mantle. The discontinuity present there is called Mohr discontinuity. Here. Is it clear? Mohr discontinuity separates the two. The crust and the mantle is separated by Mohr discontinuity. If the question arises someday that what lies there, what is present there, which layer that we discussed about the asthenosphere and the lithosphere, which is the most probability, what will be here at the Mohr discontinuity? The upper mantle and the crust comprises of lithosphere. So this is where the Mohr discontinuity will be, separating the crust and the mantle. Then going down, you will see one more, that is Ripeti discontinuity, separating the upper crust, upper mantle and the lower mantle. Upper mantle and the lower mantle is separated by Ripeti. Finally, you see crust and the core, the outer core, separated by Gutenberg, and Lehmann will be the final discontinuity separating the two crust, the core, the outer core and the inner core. These are some of the names that you need to remember. It's very easy if you work on these. So these discontinuities play a very important role. How these are judged? Based on the change in the composition of the layers. Conrad discontinuity, Mohr discontinuity, Ripeti, Gutenberg and Lehmann. These are the discontinuities present within the earth. So that is all about the interior of the earth. So we are done with today's lecture. Now we need to understand how scientists work towards understanding these layers, because we cannot go inside the earth. It's not possible. So how do we do it? That's a different topic that we'll be dealing in the next class. For today, that's all. This is a brief image for you. If you want to look at this image, it will give you a brief idea of whatever we have studied till now. This is your crust. Then you will have lithosphere, asthenosphere, and core and inner core. These are some of the layers that we have discussed. If you want to take this as a screenshot, this will help you understand. This is the basic summary of whatever we have read up until now. Is it clear? If you have any questions, you can ask me. I'll be taking your questions for some time. I'll give you a minute or two. If you have any question, you can ask me. So that is all for today's class. Any questions, you can ask me. Okay, so we don't have any questions at all. That means it's been a very good class, that you understood everything. So that is all from my side. See you next time in the next class. Bye-bye.